Okay, I want to do something a little bit different today. We have here an integral, and I want to solve this one 3 different ways. We have the integral from 0 to infinity, t cubed e to the minus 7t dt. Okay, so to get started with my first method, what I'm going to do, we're just going to do a u substitution. I'm going to do it to simplify the exponent here. I'm not going to do the whole thing, just the 7t. So we'll set u equal to 7t. And then before I take my derivative, let's solve for t. So t just divided by 7 on both sides, we can write as u over 7. Now take a derivative, so dt is going to be just 1/7 du. So then we'll just go ahead and substitute, plugging in infinity here, 7 times infinity, so we still have infinity for the upper bound. Plugging 0 in, we're just going to have 0 for the lower bound. Then for t cubed, this is going to become u cubed over 7 cubed, but I'm actually going to bring the 7 cubed out front here, because that's just a constant, and then this is going to become e to the minus u. And then for dt, 1/7 du, I'm going to take du but bring the 1/7 out front here. But then let's just multiply all this stuff together here, and this is going to give me 1 over 7 to the 4th here, or 2401. But now just like that, this whole integral, this is actually in the form of the gamma function. Okay, so here we have our formula for the gamma function. Notice we got the right bounds. We're going from 0 to infinity. We have everything set up. Our variable here is u, and the variable here is t. The only thing I can do is let's just get the exponent into this form of like n minus 1. So what I can do is I can just write this as, I can write this as 4 minus 1. And so then doing it that way, the n value is going to be just this 4 here. So this whole thing is going to become just gamma of 4. So coming down here, we'll rewrite this. We have the gamma of 4 over 7 to the 4th, just using this part. But then we can use this formula over here to express the gamma function in terms of the factorial. So we can just take this n value of 4 and subtract 1, and we can write this as 3 factorial over 7 to the 4th. But 3 factorial is just 6, and 7 to the 4th is just 2401. And that's going to be my solution for the first method. Okay, now method number 2 for this is going to be the more straightforward method. It's probably the longest of the 3, but it's just going to be integration by parts. We'll do the DI method, or tabular integration. We'll split this up. I'm going to want to differentiate t cubes. That's going to reduce. And we'll integrate e to the minus 7t. And so we're going to need to do this multiple times. So when we differentiate over here, derivative of t cubed is going to be 3t squared. Derivative again of this is going to be 6t. Derivative of 6t is just 6. And then one more time, derivative of 6 is just 0. And then here, integrating over here, this is going to be e to minus 7t over minus 7. Doing it again, integrating, we're just going to keep bringing up minus 7. This is going to become over 7 squared. Then here for the next one, this is going to become minus 7 cubed. Kind of short on space. And then for this last one, it's just going to be e minus 7t over 7 to the 4th. Now for the solution, we're just going to take the diagonals. The last row is 0, so we won't have to worry about that. So then we'll have all these. So now writing down the solution from the diagonals, what I can do is factor out of this minus e to the minus 7t, because there's going to be a negative in each term. And so doing that, for the first term, we're going to get t cubed over 7. Then we're going to have plus 3t squared over 7 squared. Then we'll have plus, over here we'll have 6t over 7 cubed. And then the last one's going to be just a plus 6 over 7 to the 4th. And we just need to evaluate this whole thing from 0 to infinity. Okay, now first evaluating this at infinity. When you plug infinity in here, because we have an exponential here, this thing is going to be more powerful than all these other terms. So when you plug infinity in here, this part's actually going to be 0. Technically, we could take a limit of this, but this is going to be much more powerful, so the first piece is going to 0. Then next we'll evaluate this at 0. So we're going to have, let me do this kind of carefully, so we're going to have minus e, plugging 0 in here, so it's going to be minus e to the 0. And then this first one is going to be 0. And the second one's going to be 0, and the third one's going to be 0. But there's no t here, so this is actually just going to give me 6 over 7 to the 4th. But then minus times minus is plus here. E to the 0 is just 1. This is nothing. This is nothing. So we're left with the final solution here of just 6 over 2401. Okay, now for my third and final method. Of course, what I want to do now is use the Laplace transform on this. So what I'm going to do is I'm just going to rewrite this and make a small change. So we're still going from 0 to infinity, t cubed. But I'm going to write this e to the minus 7t. I'm going to write it as e to the minus st. And what I'm going to do is we're just going to say we know from this, our s value, our s is going to be equal to 7. But then what we have here is just in the form of a Laplace transform. This is actually the Laplace transform of t cubed. So I can just rewrite this as the Laplace transform of t cubed And again, we have to remember the s equals 7. But we have a good formula for this Laplace transform, especially when the exponent's integers. So for Laplace of t to the n, with n as an integer, we can write this as n factorial over s to the n plus 1. So just doing that, using that, our n value here, n equals 3. So here we're going to have 3 factorial, or just 6, over s to the n plus 1, or 4. And so this is going to be our f of s value. This is going to be our solution for the Laplace transform. But then all we need to do is plug in our s equal to 7. We just need to find f at 7 using this formula. So we're just going to have 6 over 7 to the 4th, or just 6 over 2401. So there you have it, solving an integral 3 different ways: gamma function, integration by parts, and Laplace transforms. Thanks everyone for watching. Have a good day.